Muzzle speed is the speed with which the bullet leaves the gun, which is fixed in this problem. That speed is fixed. Depending on the distance of the ship from the fort, the bullet should be fired at appropriate angle theta, to reach the fort. But beyond a certain distance, the bullet cannot reach the fort, whatever be the angle of projection. This is the maximum distance required in the question. So we are using the second trajectory equation, which relates the distance r with tan theta. A simple differentiation gives us tan theta is equal to 2k by r, corresponding to r maximum value for r. So that is what we have worked out. Now, in a similar way, you can show that a shot fired from the fort at any angle cannot hit the ship if the ship is beyond a certain distance from the fort, that is downward projection. That I am leaving as an exercise, how to work out that maximum horizontal distance on the sea level. In this case, take note that a shot fired horizontally from the fort will not give the maximum range on the sea level below. That you have to take note. Okay. Now you can try that. Answer is given at the end of the question. Answer has been given. Okay. Thank you. Actually, you have to project at an upward angle, so that the time of flight will be increased. So, longer the bullet is in air, it can acquire a larger horizontal range. That is the idea that is why horizontal projection, which will reduce the time of flight, will not give you the maximum range on the ground.